So in these next two very short vodcasts, what I'd like to discuss is how we began to discover that the atom is subdividable. And the first subdividable particle that was discovered was the electron. J.J. Thomson is given credit for this, but the device that he was using is the device that you see here. This is called a Crookes tube, named after Crookes. My understanding is that they were studying things like phosphorescence, which you might have seen yourself when things sort of glow in the dark, or if you've ever been out on a beach on a summer evening and you see that sort of iridescent glow in the background. This is my cat, Midnight. He'd like to be in the video. I'm going on without the boy. So if you hook up an electrical circuit on the left-hand side at the cathode, and you continue to pass electricity over here to the anode, as the electricity passes through this device, a mysterious beam appeared. Now let's talk about what was inside the Crookes tube. This is a metal disc, and they tried lots of different discs and got the same results. It has a little slit in it, and they've coated this background screen with a phosphorescent background that would emit that glow that we were talking about. In this particular case, it was zinc sulfide. And regardless of what metal they used, they saw that this mysterious beam that passed from left to right could have its pathway deflected. And this is a person with a magnet holding the positive end next to the beam, and as the beam bends towards it, the conclusion was that whatever these mysterious rays were, that they had a negative charge. Now let's take a closer look at this in a really short YouTube video about J.J. Thomson, and we'll take it for a few minutes there.
J.J. or Joseph John Thomson was best known for two things. First was his idea of the structure of an atom, and second was his experiments with cathode ray tubes. Thomson's atomic model consisted of electrons surrounded by a soup or cloud of positive charge. It was also called the plum pudding model because the pudding had bits of raisins or other fruit suspended in it, much like the electrons of Thomson's model. Through his three cathode ray experiments, J.J. Thomson concluded that the atoms of cathode rays were made of smaller particles called corpuscles, which we know as electrons, and that those gave the ray their negative charge. He also believed that these corpuscles were surrounded by a positively charged cloud, and this was the basis of his plum pudding model. Today, cathode rays are used in TVs, computer monitors, neon lights, radar, and oscilloscopes. In such devices, different colored rays are repelled, taking advantage of the fact that they have an overall negative charge, and these produce the image that you see. And there you have it, the life of an important man of science, summed up in only 2 minutes.
Okay, so let's stop there. And clearly to me that this guy was doing some sort of video required by his chemistry teacher, and a couple of corrections and enhancements on that. They're called corpuscles, not corpuscles, just to be sure we're pronouncing it correctly. And as you saw in that model, that plum pudding model can also be thought of as the raisin bun. Now, up to now, we've done, I think 3 models, maybe 4. But bottom line is, for your exam that's coming up in a few days, you need to be able to describe the major models that we've discussed in our PowerPoint notes to date. And that would include the earth, air, fire, and water of the early Greeks. We have our Dalton's model, which thought of the atom as a solid sphere. But remember, Dalton's model has many subdivisions in its description, so be sure that you know all of the parts of the model originally and what parts hold true today. And as we got through the accidental and intentional discoveries of Becquerel and the Curies, now we're looking at a model of the atom that includes subatomic particles. So there's a couple of things I'd like to talk about on that plum pudding model. If you think of this bun or pudding as the positive matrix into which the negative electrons are embedded, that would be a good sketch for the Thomson model. Now, you and I are not made of atoms that have an overall negative charge, because if we were, positively charged objects would be stuck to me right now. So Thomson's model includes the fact that the matrix, or the bun or the dough or the pudding, whatever you want to use, is positive, and embedded in it are the negative electrons. But as you can see by this picture, his analogy is still equating the atom to be a solid sort of sphere that's positively charged with negative electrons embedded. Now along comes J.J. Millikan's understanding of what the charge to mass ratio is on the electron, and this is called the Millikan oil drop experiment. You might also be asked to explain major experimental research that was done and the models and the parts of the models. So let's take a break from me talking at you on this one and go to another YouTube video that will describe the Millikan oil drop experiment.
In 1909, Robert Millikan, working at the University of Chicago, succeeded in measuring the charge on the electron. He allowed a fine spray of oil to settle through a hole into a chamber where he could observe their fall. The top and bottom of the chamber consisted of electrically charged plates. He introduced a source of X-rays which can cause creation of charges when they strike matter. Charges produced by the X-rays attach to an oil droplet, producing one or more charges on the droplet. When there is no voltage applied, the fall of the droplets is determined by their mass and the viscosity of air through which they fall. When a voltage is applied, the droplets that have a negative charge will fall more slowly, stop falling, or even rise, depending on the number of charges on them. By adjusting the applied voltage and observing the droplets both with voltage off and voltage on, Millikan was able to determine that the charges on the droplets were all multiples of a smallest value, 1.6 times 10 to the minus 19th coulombs. He took this to be the charge on a single electron.
So, as you can see, then Millikan's contribution is to understand that the electron has a particular quantity of a charge, and that is called the Millikan oil drop experiment. So essentially he didn't discover any new particle, he was just able to fine-tune information about them. Oil is sprayed through here in a fine mister, they fall due to gravity. He applies a charge, and you can see the two plates that are here, by zapping them with X-rays right here, and the rate of the fall can be adjusted by adjusting the charge on the plates. So essentially he was able to figure out this one quantity, and you don't need to know what the charge is on an electron unless you're taking AP Chem, but do understand that the Millikan oil drop experiment allowed us to quantify the charge on an electron. So that, I think, is a good stopping point, because the next subatomic particle and structure of the atom I want to talk about is a student of J.J. Thomson, and his name was Ernest Rutherford. And you will be expected to explain in much greater detail this diagram that you see here, the Rutherford gold foil experiment. That's it for this podcast. I have one more to go, and we will be done. Take care.